area problem, a border problem, and I have a painting. Let's assume the painting's on the inside. I have a painting that's bordered on all sides by a frame, and we will assume that the frame is right here in red on the outside. The dimensions of the painting, it's 10 inches longer than it is wide. So I have width, and then I have my dimension of W plus 10. The frame itself is 3 inches on all sides. The measurement of the frame. And I'll go ahead and do, so the frame is outlined in red. The area of the frame alone is 402. So I will color in green what represents an area measurement of 402 square units. We need to determine the entire measurement units, and the entire width is comprised of the original W from the painting plus a 3-inch mat on both sides, so that's 3 plus 3 plus 6. And then the length is the original W plus 10 of the painting plus 3 inches on top and 3 on bottom, plus 6. And of course, we'll clean that up to W plus 16. So marking up your sketch and understanding the big picture is important. Now let's do a math model in words. The painting plus the frame equals the total area. So if you were trying to find a space in your home on a wall to hang this painting, you would have to set aside enough space to take both the painting and the frame, or the total area. Now let's come behind and slip in algebraic representations for each of the verbal setups. So the area of the painting would be W times W plus 10. So the area of the painting is W times W plus 10. The area of the frame is the number that you're explicitly given, 402. And then the total dimensions, one dimension is W plus 6, and the other dimension is W plus 16. So getting this set up is so important because now it's not that difficult to solve, especially since you know how to handle multiplication with binomials. So let's go ahead and clean this up. And you can see that the quadratic terms, or the two squared terms, once again will fall out on both sides. And you're left with something that's fairly simple to solve. Then you come back to the original shape, and the painting itself is a 25.5 by 35.5. And I'll just go ahead and write that down here. Going back to the dimensions in blue and let W be 25.5. So the measurements of the painting and then the measurements of the entire, the total, or the red dimensions on the outside, it's a 31.5 by a 41.5. And then determining the area of each, the area of the painting, if I multiply these two numbers together, their product is 905.25. And then the area of the total, multiplying the two numbers together. And if I take the difference between those two numbers, their difference is the 402. That's their difference. So you have a way to check yourself to see if you're right or not. Let's at least discuss setting up the second. A painting is 3 inches longer than it is wide. it is set in a frame that's 2 inches wide on each side. If the area of the frame alone, is 100 inches squared, what are the dimensions of the painting? So I'm going to set this one up for you, and then I'm going to ask you to solve it on your own. So the painting on the inside, 3 inches longer than it is wide. The frame itself is 2 inches all the way around. And then the area of the frame is 100 inches. So the green shade represents an area of 100 inches. Setting up your larger dimensions, the width now becomes W plus 4, and the length becomes W plus 7. And once again, you could do something as simple as the painting plus the frame equals the total. And the area of the painting would be W times W plus 3. The area of the frame is 100, and the dimensions to represent the total and I will ask you to finish that up, bring it to class, and then we will compare answers.